Hey guys, today we are going to continue using those sinusoidal functions, and today we're going to be doing the real world applications, the practical applications of these guys. So it's the essential question today is how do I write the equation of a real world situation using sine or cosine? And this is going to take us back to unit 2, 2.3 especially for writing the equations of sinusoidal functions. And so a lot of times these are going to be circular motion type things. You're going to see we're doing a Ferris wheel today. But as a reminder, these two functions, A, B, C, and not D, are all going to be the same once you figure out what your graph looks like. A represents your amplitude, B represents your period, or how to find your period. In order to find the value for B, you're going to take 2 pi divided by how long a cycle takes. C is your vertical shift. So how far up or down from that x-axis did you go? And then D is your phase shift, your horizontal shift. Where did your first point start? So let's begin. So we have this Ferris wheel problem. It's the fair here in Texas. You're standing in line to ride the Texas Star Ferris wheel at the State Fair of Texas. As you're waiting, you notice that while riding the Texas Star, a person's distance from the ground varies sinusoidally with time, which tells me that I know I'm going to be making a sine or cosine graph. It's a wave. You read in your official guide to the State Fair of Texas that the Texas Star has a diameter of 212 feet, and notice that it takes 82 seconds for the Ferris wheel to make 1 revolution. As you approach the loading dock, you estimate that passengers load the car 8 feet from the ground. It is finally your time to load the Ferris wheel, but once you are on, they continue to load several other cars. So that just means that they kind of bump you back while they're loading. When the Texas Star is fully loaded and begins to continuously turn, you start your stopwatch. It takes you 50 seconds to reach the top. So we're going to calculate a couple of things we need in order to make this graph. So first it asks you how high is the top of the Texas Star. Well, if it has a diameter of 212 feet and you notice that it's going to start 8 feet from your ground, that means that how high from the ground to the top of the Texas Star is 220 feet. So that's the highest point that's going to be on my graph. What time will your stopwatch read when you get back down to the bottom? Well, first of all, when we started timing, it takes me 50 seconds to reach to the top. So we're going to take that 50 seconds. The other thing I'm going to think about is the fact that it told me it takes 82 seconds to make 1 revolution. So if I'm already at the top, so if I have my little Ferris wheel and it took me 50 seconds to get up to here, I know that I have half a revolution to get down. So if I know that 82 seconds is 1 revolution, then I know that half of that, 41 seconds, would give me the 1/2 revolution. So I'm going to go ahead and take that 41 seconds and find out for me, my stopwatch read 91 seconds when I got down to the bottom. Okay, how much elapsed time will it take to reach the top of the Texas Star for the second time? Well, remember, I've gone all the way around. This is me now, and that took me 91 seconds to get to that point. And then again, I'm going to go 1 more half revolution, which takes another 41 seconds. So that's going to take 132 seconds. So all these things are important for us to be able to graph a whole cycle of this graph. So the biggest thing about this is we need to make sure that we label critical points and we label our axes so we know what we're talking about. So I'm just going to go ahead and draw on some axes. On my x-axis is going to be my independent variable, and that's time. That's what we're measuring in, and we are measuring in seconds. On my my y-axis, it'll be the height, and we are measuring the height in feet. Okay. And so now we're going to go ahead, I'm going to label my heights because that's pretty straightforward. The lowest height that I'm at would be that 8 feet, that loading point. And then the highest point that I'm at is that 220 feet to get to the very, very top of the Texas Star. The next thing I'm going to label are the points that they gave me and some of those second values on the x-axis that I found. So we knew that it took 50 seconds for us to reach the top. It was 91 seconds for us to get back down to the ground, well, to that one starting point. And then if I was going to go back up, that would be at 132 seconds. So I'm going to go ahead and plot those points. At 50 seconds, I was at a high. At 91 seconds, I was at a low. And at 132 seconds, I was at a high again. I'm going to go ahead and connect those dots because it told me it was a sine wave. Oh, this is going to be bad. Oh, could have been worse. Could have been worse. Okay, and so that's what your picture looks like in general. Not too bad, not too bad. The next thing I have to do though is write an equation for the sinusoid. And again, this goes back to that unit 2 stuff. So remember, we're always going to have this equation, c plus a trig function b times x minus d. Now the one thing I want to point out is that when we are worrying about real world things, we don't tend to know the middle point. If I was to try to write a sine graph, I would have to know this sinusoidal axis and know like this is the time that it started. So most of the time you're going to be writing this as cosine. If you write it as sine, it's not wrong, but it's easier to find a high point or a low point of one of these real world graphs. So when I look at my graph, there are a couple of key features that I need in order to get all these pieces. And the first one is my C value, that sinusoidal axis. So C should be right in between your highest and your lowest points. And so you can kind of think about it as taking the average of your two things. So if I add up the two things that I have, 220 plus 8, divide them by 2, that would get me that middle value, and that happens to be 114. And if you notice, that's an equal distance away from 220 as it is from 8. Okay, then your A is just to figure out your amplitude. And so I want to know what is the distance from the top to the middle point or from the bottom to the middle point, because that should still be the same distance. And so if you go ahead and I can take the top down to the middle point, so 114, and that would get me 106. And if you notice, going from 8 to 114 would also give me 106. So it's just kind of a matter of preference, how you want to find your amplitude. Okay, so that's on my y-axis stuff. Let's look at my x-axis stuff. Sometimes this gets a little bit more tricky. So remember, to find b, you're going to take 2 pi and divide it by the period, or how long it takes you to get from one point to the same exact point. And since we figured out that we started here at the top, we were at the top at 50 seconds, and then we were back at the top at 132 seconds, that is an entire period of my graph. So I could just go ahead and figure out how far away that is. So if I took 132 minus 50, that would get me the 82 seconds that it took for me to go from top to top. Okay, and so then my period is 82, so I would take 2 pi over 82 and go ahead and leave and simplify that down if I can. So pi over 41. Okay, so again, you're just trying to find what that is. And also, if you notice, that was in our question. It told me it was supposed to take 82 seconds for me to get from a full cycle of my graph. So we kind of had that in there. Okay, remember, D is the only thing that might change. This is where we're thinking about my starting point. And so there are lots of things you could do. If you like to do sine graphs, remember, you'd be looking for a middle point, but you want a middle point going up. Now my problem with that is I don't really know what that point is. I could do some more math and figure it out, but I'm lazy. So I'm going to go ahead and find one of those top points, and since a top point means it's a cosine, I have a top point at 50, or I have a top point at 132. You also could get creative and pick a bottom point and make it a minus cosine, and then it would be 91. Okay, so with all of that information, I can now make an equation of my graph, and it would be y equals, my c is 114, plus 106 was my amplitude, and then I'm going to use cosine. I have my b value was pi over 41, and then x, and I'm going to use just that 50. Remember, it's always a minus in there, so if it was negative, you would put it positive, but this would be the equation that represents this motion. Okay, and then we're going to use this equation in order to extrapolate on the information that they gave us. So they didn't tell me these different time periods. They didn't tell me how high off the ground I was. So I'm going to use this equation that I just developed in order to predict my height. So this is when I'm going to use my calculator. Most of these are going to be easiest to use your calculator unless you feel like being super ambitious. So I'm going to predict my height above the ground when t equals 15 seconds. Because if you remember, when I didn't start quite going up for a little bit. So we're going to use my calculator. And when I type this in my calculator here, I'm going to write it out for one of these. All I'm doing is I'm going to plug in 15 wherever I see an x. 15 minus 50. Okay, and then you're going to get some value. Make sure that you're watching your parentheses, so when you type this in, that you type in 114 plus 106. You make sure that you're in degrees, or sorry, radians or degrees based on the question. I used pi, so that means I'm in radians. Remember, if you want to make a fraction, alpha y equals, enter. We're going to have pi over 41, parentheses, and then my x now is 15 minus 50, close all my parentheses. Okay, so I'm going to get that I was about 19 feet off the ground, and remember we can round this to 3 decimal places, so 19.006 feet. And you'll do the same thing for 75, so you would just go in and plug it in and figure out what 75 is. And I'm going to be super lazy and just copy paste my thing and go change that to be 75 instead, and I would find out that I was about 78 feet above the ground. So make sure that when you're getting answers here, they make sense. Okay, the highest that the Texas Star went, we already said, was 220. So if you get an answer bigger than that, you know you probably should watch it. If you get a negative answer, we really should watch it. Okay. Now, one of the cool things that your calculator can do is if you take this equation and you go ahead and you put it in your calculator into your y equals. So if you go into your y equals screen and you type in all of this business, pi, oh, yep, I did 1 second. Nope, I have no idea what's happening now. I'm breaking things. Pi over 41, again, all the parentheses. The worst your calculator can do is tell you have too many parentheses. And then you can graph it. Now, if you graph it, you're going to notice that you're not going to have your entire screen on this because your window is normally 10 by 10. So I'm going to go ahead to my window and reset it. And wow, mine is not even 10 by 10. I have no idea what's happening here. So I'm going to go ahead, because I'm talking about time here for my x, I'm going to just have it be 0. And then for my x max, we knew that it took me about 132 seconds to get to the top, so 132. Then I can change my scale to be whatever I want. I'm going to make it just like 10 or something so it doesn't look too messy. My y's, my minimum value I went was 8. So you could make this 0 or you could make it 8, your minimum value. Your max, though, was 220. And then I'm just going to go ahead and make my scale by 10 again. So then when I graph this, there's my beautiful sinusoidal wave. And so if you wanted to find a specific x value in here, if you went to second trace or second calc and you said, I want to find a value, you would just type in, I want to know what it is when x is 75. And check it out. It's the same answer I got before, 78.170. Okay, and then I can look at it and I can do interesting things like 5 minutes. So you have to watch what units you're using here. So on that one, if I wanted to find 5 minutes, I would go to second trace value and I would do 5 times 60 because there's 60 seconds in a minute. Now you're going to get an error. And the reason that this happened is because your window is not big enough. It doesn't have 300 in it. So if I went back in here and I changed this to be like 350, perhaps, then I could go ahead and now this is going to have that value in it. So I would do second trace number 1, 5 times 60 or 300, and that would get me that I would get about 215.06 feet. Okay, and so then when I have questions like number 7, how high were you when you started your stopwatch? Well, I started my stopwatch when time was 0. And I can go into my calculator and just ask it, hey, where was I when time was 0? And I'll find out that it was 32 point blah, 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 blah feet. Now, if I write that down, let me make sure I write that down before I forget it. It asks me, were you moving up or down when you started timing? And so when I look here, it's kind of hard to see because my thing totally squished it. But if I look at my graph, I want you to go away. There we go. If I look at my graph, here was 0. And if you notice on your graph, you are actually moving down. You weren't moving upwards, you were taking the descent. And that makes sense because you kind of went up your Ferris wheel a little bit and then you came back down to start taking your journey around. So you were moving down. You just have to look at the picture for that. Then on number 8, it asks you what is the value of the second time you were 100 feet off the ground. So if you remember back to your equation, your dependent variable was the distance. So we want to know where is y equal to 100. So in my calculator, if you remember from the other day when we talked about solving these sinusoids, if I take this guy, this is my equation, in y1, and then I put the y value I care about in y2, I can look at my graph. And I want to know where is that second point. So the second point that it's 100 feet off the ground. So this was the first one. This is that value I care about. So if I do second trace on my calculator, and instead of picking 1, I pick 5, the intersection, and I go scroll over, oops, I'm way far over there, using my left or right arrows to that second place. Eventually I'll get there. It's going to keep going once I stop clicking. This is terrible. Okay. You get kind of close to it if you can. You press enter 3 times, and you're going to find that that intersection was at 72.229 seconds. And you can do that same thing for this next one. So if, oops, I totally closed it. If you wanted to find out where it's 175, you just go down, change this to be 175. And again, you're trying to find the 5th time that you're that many off the ground. Let's let it graph. It's like, nope, I want to go really slow. Second trace, number 5. And again, I want the 5th time. So this is 1, 2, 3, 4, 5. I want to get over there. Get kind of close to it, press enter 3 times, and you would find out that that happened at 201.502 seconds. Okay, and so again, that was, we typed in y equals 175. So that is word problems in a nutshell. We're going to practice more of these for the next couple days. The biggest thing is drawing that picture. If you can draw the picture, then you can find all of the pieces of information to write the equation, so then you can just throw it in your calculator and find out the specific values. Have a great night.